sorry for those who've seen it, might be a bit boring. Yeah, here's the link and the QR code for the same link. They are on the slides. I think Barbara will also share them afterwards, so you can access the slides here on the web. But you can also use it live to see go back and forth on your mobile phone or whatnot. So, but a few things about me. Who am I? Well, that's my legal name. I also like all of those names, but my brain is trained to Jackie, so feel free to use any of the names, but for the others I will need some time myself because of resources, because I tend to do a lot of other things, often too many other things, but I teach at the Angewandte as well, a course on web-based game prototyping and machine learning, and at the Technical University a course on feminist techno-science studies. And then I have some side web projects, mostly for NGOs, mostly it's WordPress-based, rather simple things. And then I'm co-organizing the Feminist Linux meetup, and sometimes other community stuff. You can find more details on my webpage. But now to the contents of the talk. So first I want to give you a very short history of cloud computing. How did it come about? How started all of that? And where are we now? Then a few of the basics of what is virtualization and containerization, and that will then lead to maybe to the things you will hear later in the other talk about DevOps, because all of that builds, of course, on containerization and virtualization. But I just want to give you an insight into the underlying mechanisms of what builds the cloud. Then I also give you a short overview of what types of clouds do we have, or cloud technologies, or cloud layers. And when we talk about clouds, of course, we have to talk about the weather and the climate. So I have a few references to try to figure out, well, do clouds cool the climate? And then we can also discuss this and all the other things. And if time permits, I have a few live cloud examples in the broadest sense of the word. And then afterwards, some announcements and the Docker intro workshop teaser. So, yeah, sorry, I did forget to prepare that one. I used it in the last talk, so there is no Slido, it's not active. But maybe then we have more time for demos and stuff. But maybe just signal with your hands, how much cloud knowledge do you have, from, well, I know everything about the cloud, to I don't know nothing. Okay. Yeah, so maybe for most of you the talk might be boring, but I'm not here for you, I'm here for those who want to know more about cloud. So yeah, short history on cloud computing. But also, we have a lot of knowledge here in the room about cloud, so feel free to interrupt me anytime if you have some correction or extension, also if you have questions, of course. So, how did cloud computing come about? First of all, what is it? According to Wikipedia, I like it because it's a very broad definition. Cloud computing is the on-demand availability of computer system resources, especially data storage, cloud storage, and computing power without direct active management by the user. An important thing here is not, well, is it computing, is it cloud, is it network? But the important thing is without direct active management by the user. So you can get some kind of IT service or infrastructure without the need to actively manage it yourself. I mean, at some point you usually have to go to a cloud provider, get an account, maybe add some payment credentials, and then click on I want to have that. But then you have it. And there's no other management needed apart from that on a very basic level. So that's what cloud computing is. But that also means that it can be very different things. So how did all of it start? We could say, actually, maybe it already started in the 1960s. Back then, there were big mainframes, only a few companies had them, often banks, for example, and they needed them because they had to do some, back then, very computationally intensive stuff. Now we would say, well, peanuts. But back then, well, they needed whole rooms full of computers just for this one thing, but they also didn't need it all the time. So the idea came up, well, we could share it, especially in times where we don't need it. And this concept, it's a very, very rough definition, is time sharing. And incidentally, it's not a lot of different from the origin story, for example, of one of the biggest cloud providers, Amazon Web Services. I mean, they didn't start with cloud technology. They started with selling books and stuff. But they needed lots of resources, for example, for Black Friday or whatever, but they didn't need the resources all the time. So they thought, well, in those times where we don't need the resources, we could share them or rent them to other people. And that's how basically it started. And then, of course, the whole cloud business took over to some extent. But back then, it just meant that you got some time slots on those big mainframes, and you could use it for whatever you needed to do. Then also in the 1970s, the cloud was used as a symbol to hide complexities, kind of. Since then, it's used as a symbol for networks. It doesn't necessarily have anything with cloud computing to do, but the common thing is that you have a cloud and you just say, okay, I have my notebook, I have some server, I want to reach it, I know, okay, I have my internet access provider, they have some router, and then the rest of that, well, that's the internet. Vast network, interconnected networks, well, this ambiguous cloud of infrastructure. So you don't care, you don't need to know how it works, but you know, once you get into the cloud, you get out there. And probably what also, I'm not sure about the etymology of cloud computing exactly, but one commonality is that you hide some complex infrastructure which you don't need to know about because you're just using it. Like when you click on the thing and you have a compute engine and it's there and you don't care how it is managed. So and then only in the 1990s, cloud was increasingly used as a metaphor for virtualized services. So if you had websites or anything, a bit in the sense of today already that you could get something without managing it yourself. But really then only it started in the 2000s, in the early 2000s. For example, Amazon Web Service was created as a subsidiary of Amazon in 2002 and went online in 2006 with their S3, so the storage service, and the Elastic Compute Cloud. So the first two basic forms of cloud, storage, and compute. And then a lot more was added later. And in 2008, NASA's Nebula came out, and the Google App Engine. And in 2010, Rackspace teamed up with NASA to create OpenStack. And OpenStack was the first, biggest, probably open source cloud infrastructure management software, let's call it like that. And also Microsoft Azure came out. And then in 2012, 13, Google Computer Engine, and finally in 2014, this is important, cloud computing was foaled as a son of distorted humor. Is anyone into horses?
Catherine is.
You might know that who's foaling what? Well, horses are foaling children. So let's see. Didn't open. Damn, it should open a link. I want to show you cloud computing. Here. This is cloud computing, a racing horse. The son of distorted humor. Apparently, racing horse names are subject of distorted humor. True. So, but yeah, that's a really funny side fact. But why isn't it not just only funny? Because apparently in 2014, cloud computing was a thing everybody knew about. I mean, if you name a racing horse, cloud computing, it's apparently a thing everybody knew that there is a thing like cloud computing. I mean, nobody knew what it is, but everybody knew there is the thing. Today, maybe we know a little bit more. Maybe sometimes we still don't know what it is. But we could say since 10 years, and it's only 10 years, cloud computing was a thing that everybody knew that we'll build on. But it's only 10 years. You need to remember that. And I mean, maybe 10 more years since the first early adopters started to use it. So what what's the technology underlying all this cloud stuff? It's virtualization and containerization. What is virtualization? Or hardware virtualization. Generally, virtualization means creating a virtual machine with virtual hardware in which an operating system can be run as if it would be installed on its own computer, like on physical hardware. So what does virtual hardware mean? Well, basically on a computer you have running a software which creates an environment in which you could put code which then is executed actually by the software, but in a way as it would be executed on your own processor. You could sometimes also say it's like a form of emulation. So one machine just acts as if it would be another machine, only that the comparison is not super good because emulation usually is not, or virtualization is a very performance focused version of emulation, let's say it like that. But maybe we can discuss that later too. Important when it comes to virtualization that you usually have a host which contains some form of virtualization software. Ideally, it is hardware assisted, which allows us then to create virtual machines on which guest operating systems can be run. So it's the virtualization host, and the host could be my notebook here, for example. Usually it will be some rack-mounted server in some data center, but it could be just a physical computing device. I mean, I think you could even use something like that and create virtual machines on that. So that would be the host. And in those virtual machines are the guests running. So what then is containerization? It means not creating virtual machines, but creating multiple isolated process environments that can run on the same operating system. It is a form of virtualization, but it's a form of operating system level virtualization, technically. And maybe it becomes clearer if we look at that chart. Can you see that from the back also? I took it from the Kubernetes page. In some tutorial they have that in there, and they just compare the traditional deployment with the virtualized deployment and the containerized deployment. In a traditional deployment, let's say you just want to install some app, a website or a mail server, a web server, a database, whatever. Well, usually we'll have some hardware, something like this, or more likely some rack-mounted server in the data center. But it really doesn't make a difference. I can run the same thing here. Then on this hardware device, you have some operating system. On the operating system, you run apps like a web server, Apache, Nginx, a database, Postgres or MySQL or anything, whatever you want, whatever you can run on your operating system. And that would be the traditional thing. So you would either set up your own device or you would rent a server, a physical server at some data center, but you would be responsible to do the whole managing of this physical server. So the virtualized deployment looks a bit different. Still, well, you need some hardware, something where code runs on. On this hardware you have an operating system, and on the operating system you have a hypervisor. This is the software part, the part of the software that makes sure to be able to create this virtual environment. And there's a special form, the most common form in data centers probably, which is bare metal virtualization, where you have specialized hypervisors which don't need a full operating system. So it's much more efficient. But the idea is always, well, you have to have some base software which allows to run code in general and to create this virtual machine. And in the virtual machines, they are separated, and then you can run the same thing as in a traditional deployment. You have an operating system, and you have some binaries and libraries. Well, you would have that here as well. And with those, you run apps. But the thing is, this one could be a Linux system, this one could be a Windows system, and you could have a Mac OS, whatever. So different operating systems, because they are really, for the operating system, it looks like it would be on its own machine. And now in the containerized deployment, again, you have the same thing. You have an hardware, something where code can run on. It's all, because most of you might also have heard the term serverless. It's a very funny thing in the recent years, and everybody has to mention that serverless, of course, needs servers. Code always runs on some hardware. There's nothing without servers. Yeah. So you always need hardware, and you have some basic application there, which is the operating system, and then you have a container runtime. And this would be, for example, Docker or Podman, and this container runtime just creates this separated virtual, not virtual, but this compartmentalized processing environment. So in every container, it doesn't look like it's its own operating system because it uses the same thing, the kernel here. That's why usually everything which is containerized is running on Linux, because Docker was built for Linux. There are ways to run Docker on Windows or on macOS, which actually uses funny virtualization workarounds, because in the end Docker is run on Linux, and the applications you run in Docker containers are Linux applications. There are also workarounds to make Windows applications run in Docker containers and so on. But the idea is the thing run in here uses the same kernel as the operating system, which makes it much more efficient. And you don't have to spin up the whole machine. With a virtual machine, you have to go through the boot process, like with your own machine, because really it's working like just a physical machine, only it's virtual. You don't need anything of that with the container, because you're using the same operating system. You just compartmentalize all the binaries and libraries that you need and bundle the apps with that. And that's why I can run this container without having myself install those libraries. And my coworker can run the same container, although they have maybe a completely different Python version than me, because in the container, the proper Python version is bundled and everybody can use that. So that's the core difference between virtualization and containerization. Do you have questions so far? Or additions?
What is hypervisor?
The hypervisor is the kind of software that allows to create this virtualized hardware on which you then can install the operating system. So it's a piece of software, and for example, if we have time, I can show how this works on my computer. It's a Linux distribution, and there it's using KVM, kernel-based virtual machines, which is the kind of the hypervisor, which is integrated in the Linux kernel. But there are others, and there are bare metal hypervisors. Like I think Proxmox has some, and then there are others which you would then run on a physical device, so you don't have to have the operating system on this level. So kind of this combination, let's say. It's not a full operating system, just the hypervisor. Other questions or additions?
Are there any cloud services that offer non-Linux
Yeah.
service?
Yeah.
Why?
But yeah, because cloud is very broad, but we'll get to that in a minute. Types of clouds. So this was just to say, okay, how does generally the principle, the paradigm of virtualization and containerization work? You could implement that with any operating system, with any software, with any device. But there are some standards and trends, of course. But what you then can do with clouds is quite different depending on the use cases and needs. And usually you have some end devices which you want to use with the services you get from a cloud provider, but then you have your cloud basically, but in the cloud you have quite different services depending on the provider, but all of these could be services of a cloud provider. And on the infrastructure level, we have the very classical things like compute, infrastructure, block storages, network. So this would be really a virtual machine. So I go into my cloud provider's web interface and say, hey, I want to have a virtual machine. I click on it and it's there and I can use it. So this would be like this very special case where I just get the virtual machine and all the rest I do myself in the virtual machine. I set up my software and do everything myself. And there are good use cases for that. And then maybe I also rent some block storage because the virtual machine needs more storage for the database. Maybe I have several virtual machines that need to be connected in a network, which is separated from the outside world, then I do that. So I'm managing my own infrastructure, but it's a virtualized infrastructure. So I don't have to take care of, well, now the hard drive got old, I have to change it. I don't care, because the virtual hard drive is already up. And the cloud provider takes care of changing the physical hard drive if it's reached its end of life. But often I don't want to manage all these things, install my Postgres into my virtual machine. I just want to have the things I need to run my Python, my Django application, for example. So I need Python, some Python runtime environment. Maybe I need a database. Maybe I need a message queue, and a web server maybe, and that's hosting my Python application. But I don't want to take care of installing and maintaining all of that. So I can go to the platform level and just get from my cloud provider, if they offer it, for example, a Python runtime environment connected with the database, and then I just put my code there, and then it runs. And that's much more comfortable if the only thing you're doing is producing this Python Django-based web application. Then you might not want to take care of the whole infrastructure below that. And then even one layer above is the application layer, where I say, well, I don't even want to develop my own application, I just want to use it. For example, content management systems, monitoring solutions, communication solutions, collaboration tools, finance, whatever. Basically every application probably could be cloudified in some way. And then you just say, okay, I want to use that. Maybe I can customize it a bit the logic, but basically you're using the software as it is, and the cloud provider just gives it to you. And these are the three layers, and that's just a different categorization of the same thing. While the infrastructure layer, this is the thing we call infrastructure as a service, where we rent out the virtual machines and so on. And the platform layer is the platform as a service, so you rent execution runtimes, databases, and so on. And the software as a service, where you really say, okay, I want, for example, to run Nextcloud, another cloud thing, which is just the software if you don't maintain it yourself, and your cloud provider just says, hey, you can have a Nextcloud with, I don't know, 2 terabyte storage. Just give me $259 each month or something like that. And then you click on it and you get it. And then you have some cloud software, but actually it's a software as a service, because you're not managing any of the technical underpinnings of the whole Nextcloud installation. And then there's one different categorization of clouds, which is the public versus private thing. And usually you have huge public clouds, and public doesn't mean all the thing I do there is public. It's called public because the providers are public services, not public services. Well, they're private companies, but it's out there on the internet publicly. You can go to AWS, Azure, whatnot, or Hetzner in my case, and you can just say, okay, give me some cloud infrastructure. And the public comes from that you are sharing the whole same infrastructure with basically everyone else. If I go there and rent out the virtual machine, all of you can do the same. So I have to be aware of that. I don't know exactly where it's running. Usually now you can say, okay, I want to run it on the data center in Frankfurt or in the US, if I don't need to care about GDPR or wherever. So you have some kind of control, but basically you don't know where it's running. You don't know on which machine it's running. You don't know who your neighbor is. Might be someone malicious. So this then would speak, for example, for private cloud or internal cloud or on-premise. There are some differentiation. We could also talk about that, but the whole idea is that you say, okay, I want to use cloud technology, but I have really a strong need to be able to say this data is on my computers in my server room, for example. Then you would go to the private cloud, so you can actually host it in your system. You could set up whole OpenStack stuff, your open source software, so nobody else is involved. But there are even offerings from cloud providers to put some parts into your own infrastructure. And that's where it also often comes to a hybrid setting, where I say, okay, some things I don't care about where they are, or as long as they are inside the European Union, for example. That can be in the public cloud, but there are some very sensitive things which I don't want to deploy there, so I'm deploying this in the internal cloud. But you're using the same cloud technology because it's more manageable, because the people who need to deploy it only need to be familiar with the same kind of technology. So that was it already about the cloud, what I wanted to tell you. Now, do you have questions on that or comments? Or shall we discuss later? Now, just some notes on the climate. because there is often talk about, well, cloud technology is very important, and I just realized I forgot one slide in the beginning. We'll get back to it later. My opening. Well, do clouds cool the climate? I did the talk first in 2001, so the sources are mostly from 2000, around 2000, but I think not a lot changed since then, but we can discuss that as well. There's the argument that clouds can be used for greener IT. And then a lot of people did research on that, and the New York Times reported in some of the research and said, well, the computing output jumped sixfold from 2010 to 2018, but the energy consumption rose only 6%. So something got more efficient, but still we used more energy. Ernst & Young did look into some studies, and they found out that generally 4% of global greenhouse gas emissions are accounted for by digitization, but that's really digitization as a whole. It's not just cloud computing. But important that rebound effects cancel out 10 to 30% savings from energy efficient tech, which means, maybe this is also what happened here, well, we curate more efficient technology, more energy efficient technology with cloud computing, and then we say, well, we are so efficient, let's put up another app. And then we are using more energy. I mean, more efficiently, but still we're using more energy, and that's a bit of the rebound effect. There was another article from Jack Center where they said, well, that there are specific gains in operational hardware and infrastructure efficiency, and also in exploiting renewable energies, because if you do that on scale, you can do that better. But they also highlight that there's still the responsibility of devs and the dev teams to actually write efficient code. Because, yeah, how much does it help if you make the hardware, for example, or the cloud management technology super efficient, but then everybody says, well, I don't have to care anymore, I just write super inefficient code. And then on a different level, very macro perspective, maybe Greenpeace had this report in 2020, Oil in the Cloud, where they looked into how the big three cloud providers, so AWS, Azure, and Google, are implicated in the exploitation of the planet for even more oil, countering the green cloud efforts. Because they have green cloud efforts, and they are actually quite good, also because they can do it on a scale. So they have very green clouds, but it's countered by the fact they often support big oil companies with that. So it's a different trade-off. Yeah, so that were just a few remarks, and now to the slide I somehow lost. Who knows that? that should have been in the beginning of the talk. What's a cloud? Well, there is no cloud, just other people's computers. I mean, this was a meme probably in the early 10s already. So when cloud computing took off, then also like free software people here from the Free Software Foundation Europe said, well, there is no cloud, it's just other people's computer. And yes, it's true. But now we've looked into what cloud is, and now we come to another perspective on that. So, well, what is the cloud? And I looked into an article Mary Branscombe did for CDNet, where she says, stop saying the cloud is just someone else's computer, because it's not, because the cloud is, and this is a quote, the cloud is a hyperscale automated computer farm run by someone who's better at automation and security than you and can buy electricity and servers and network connectivity more cheaply than you, because they buy so much of it. And if you want all of the benefits of cloud, you have to design things to achieve that. So yes, cloud is still someone else's computer, but this someone else is just able to do that on a scale. And you could do that yourself. I mean, I wouldn't start trying to do that on my notebook, but I could. But if I really would like to do that in a secure and reliable way, I will be so preoccupied that at some point I will just do cloud technology, and then I will become a cloud provider and not do the things I before did. And that's a trade-off kind of. So there's cloud, but of course you always have, it's always about trust. I mean, when we use the internet, it's about trust. The question is, which cloud provider do you trust more? But I'm sure they are better at security than you are. Not because they know more about it, because they are super wise, but just you're one person maybe. So that's always to think about. So that's it. Hopefully I raised some questions. Maybe I can answer some of them if you have some. Just a link to the slides again and my contacts. Yeah, that's it with the announcements. Thank you. I think we have a short break now.
Thank you.